Algebra 2, Lesson 21. We are on page 102 today. 21a talks about scientific notation, and 21b, which we'll get to later on this lesson, talks about statements of equality, and we're going to be deriving equations based on statements. And it's not going to be numbers and quarters this time. It's going to be just statements that we have to change into equations, and you'll see how we use substitution and elimination in order to solve for those. Let's start with the first part of scientific notation. And in 21.1, you're going to see this problem. And this problem is maybe looks a little bit complicated. You have scientific notation that you're going to have to change into something that is workable. And at the same time you do that, we notice that there's a division problem going on. So we're going to divide the two top terms, which are being multiplied, by the two bottom terms that are being multiplied, which means that we're going to have to deal with coefficients. So let's start here. If you move a decimal from left to right, okay, so if I have the number 4,000, like we have up here, and I put this in scientific notation, I'm going to say the decimal is going to be moved from, I'm going to use this one, right to left, okay? Where did my marker go? There we go. Right to left. So here's the decimal point. I'm going to move it over 1, 2, 3. So I'm going to say 4 times 10, and notice I receive a positive 3. And that means that the 10, when multiplied, is going to give me 3 zeros, and I add the 4 here, it gives me 4,000. Okay? So this 4,000 right here is represented here, and it's 4 times 10 to the positive 3. Let's look at this one. Okay? Here, we're going to move from left, the decimal from left to right, and we're going to say that 0.0003 in scientific notation, we're going to move it over 1, 2, 3, 4. But notice it already has a negative 6. And if we move it from left to right, we still stay with negative. So we're going to add to those negatives, if you will. So 1, 2, 3, 4. Which means that we're going to say 3 times 10. We already had a negative 6. And then we're going to add another negative 4 to that, which yields a negative 10 total. So it's going to be 3 times 10 to the negative 10th power. Okay? So let's put a negative 10 up here. Do the bottom ones, okay? This already has to the power of 15. But again, we're going from left to right. So we're going to go 1, 2, 3. So it's going to be 6 times 10, and then we're going to say minus 3, so it's going to be to the 12th power. This one, we're going to go from right to left, 1, 2, 3, so it's going to be 2 times 10 to the positive 3rd power. All right, so we've done all of our powers here, okay? You'll notice here that the multiplication now are whole numbers, and that's exactly what we want to do. So 3 times 4 is 12. 6 times 2 is 12. All right? But we also have our powers to deal with, okay? They're both times 10 to the power, so let's add these two, okay? So negative 10 and a 3 is a negative 7. 12 and a 3 is a 15. And what we're going to do is we're going to put this up in the numerator. So when we do that, this 15 becomes negative. 12 over 12 is literally 1. So we can say 1 times 10, and then we're going to say negative 7 plus, or a 15, right? So we have a negative 22 as far as the power is concerned, okay? So just so you see that, 12, oh, you know what? I made a mistake here. I forgot to add that 4, so this should be 7. Anyway, you've got you've got a couple of examples here to show you how that works. So anyway, it's not that difficult as far as a problem is concerned. Just make sure that you watch all of these powers, okay, and appropriate them the right way. All right, let's go to the next set of problems. In 21b, let's look at 21.2 where it says the ratio of two numbers is 3 to 4. Okay, ratio of two numbers. That means we have n, which is the numerator, over denominator, which is equal to 3 and 4. Okay, and their sum is 84. So numerator plus denominator equals 84. Now, you might not think we have two equations, but this will give us an equation, and this definitely is an equation, okay? When we have an equality, we can cross multiply. So our equation A here is going to be 4n equals 3d. Our equation B is already set up, n plus d equals 84. All right, how do we get this essentially to work? Do we know what d is equal to? Yeah, we can find either what n is equal to or d is equal to using this equation, and then we can substitute that value for either d or we can substitute that value for n. So let's just for the sake of it use n, okay? Let's subtract d from both sides. D cancels out here, so we have n equals 84 minus d, which means that we're going to use this and substitute it into that spot, which means that now we're going to have 4. Well, what does n equal? 84 minus d equals 3d. Now we can distribute, and 4 times 84, 4 times d equals 3d, and so on. And we can do that pretty easily as far as that is concerned. Okay, so this is a pretty simple setup, and you can find out what both the numerator is and the denominator is. Okay, because once you find d, you can plug d back into this original equation and come up with n. Okay? All right, let's look at the next one. Okay, 21.3 gives you just a different look at it. It says the sum of two numbers is 128. In these types of problems, you're going to use a L and an S. L stands for large number. S stands for small number. Okay? Both are just dealing with numbers, because usually you have a larger number plus a smaller number. You can have the same and the same, but we're not going to look at that because that's kind of boring. We want a large number and a small number. So the statement says the sum of two numbers is 128. So we're going to say large number plus small number equals 128, because these two equal 128, and their difference is 44. So we can also say that large number minus small number equals 44. You know what's great? This is an elimination problem, and it's so easy because the small number cancels out. So we have two large numbers equals, and then we're going to add these, okay? And the reason is because we want to find out what that large number is equal to. And if we divide 2 and 172, let's go 6, 7, 8, 16, and then 6, so 86. So our large number is 86. Now, we can go back up to and put it into any of these. So we said large plus small equals 128. And if we figured out what large is, that means that we can replace large with 86. Okay? Which means that we're going to subtract 86 here, and we can come up with 42. Our small number equals 42. Okay, so that kind of problem is really easy because you can use elimination to come up with that. And when you do use elimination, if you set the problem up right, you'll get an easy answer every single time. Okay, you want to look for which one you can eliminate. Sometimes you'll eliminate the small number, sometimes you'll have to multiply by like a -1 to eliminate the large number or whatever the case may be. But remember, if you have to do that, you have to apply it to every single term, not just the one you're trying to eliminate. All right, that's your lesson today. I hope that you guys do well with that.